Okay, we've talked about the different types of nodes in an ISE deployment in the previous slides. Now, let's talk a little bit about how the data flows between those type of nodes and how that's going to impact how you deploy your ISE environment. A lot of times people don't always understand what type of data flows between which nodes, and it can sometimes cause challenges in a failover scenario in their environment if they don't understand what to design around. So let's take a look at how this all goes together. I'm going to draw a very simple ISE deployment. I'm going to draw two pans. Now remember, the policy admin node, he's the king of the world. He's responsible for all the database replication in the environment. One of these guys is the active pan or the primary pan. One of these is the secondary or a backup pan. Now I'm going to have my monitoring nodes. So I'm going to draw two of those. Now, if we remember right, both of these are active. What I might not have mentioned before, but let's just clarify now, is that the second guy is actually going to be read-only. So there's a primary active and a secondary active monitoring node, but the secondary is going to be read-only. Now, if we look at the policy nodes, let's just draw a couple of those. And then we'll just draw a couple network access devices. Now, if we look at the type of data that flows between the different environments, I'm going to use some different colors to differentiate the type of data. I'm going to use green, and we're going to call this our database or replication traffic. I'm going to use orange. I'm going to call orange our logging traffic. I'm going to use yellow. I'm going to call yellow our radius traffic. And I'm going to use pink. And pink I'm going to call, for lack of a better word, reference. And we're going to see what that means here in just a second. So if I look at those four different types of traffic and put those to the different node types we have, let's see kind of what that looks like. So for my database traffic, remember, my pan is the king of the world. He's responsible for all that replication and keeping track of it. So he's going to continually monitor, or he's going to continually replicate between the active primary node and the second primary admin node. He's also going to get a copy and send a copy of all the database updates from the PSNs in the environment. And keep in mind, because he is the king of the world, all this happens in a hub and spoke type topology. So he basically receives all the updates and is responsible for sending all of those back out. So what that basically means is, if this policy service node gets an update and he needs to tell this policy services node, it's going to go to the primary admin node first, and the primary admin node is going to send it back down to the other policy node. Now, let's look at the logging. Remember, both logging nodes are active. Again, there is a primary and a standby, but they're both active. And what that basically means is they're both going to get a copy of the logging information from the PSNs. Okay, so as we see, a duplicate copy of the logging messages are going to be sent to each of the monitoring nodes. Now, if I look at my radius traffic, the radius traffic is going to be between the network access devices and the policy node. And because we're hopefully in a primary, secondary type scenario, it's going to look like this. For those of you familiar with basically layer 3 designs, this is our typical bow tie scenario. And then reference, what does that mean? That means I'm going to reference another node and pull that data up for display and presentation to the user via the policy admin node. The primary monitoring node is going to be known to the PAN. So when we go to Radius Live Logs and we pull that information up, he's going to reach down here, grab a copy of that data, and display him up here. So now that we understand all this, how does this impact our design and what are the considerations we need to know about? Okay, number one is latency. Latency of 300 milliseconds between any two ICE nodes is what's currently supported in the current versions of ICE. Some of the other things that I need to be careful of are bandwidth and just number of transactions. I'm going to call it transactional. So which type of traffic is more latency, bandwidth, or transactional sensitive? Well, pretty straightforward. Let's take a look at the database replication. That's going to be pretty bandwidth intensive, and the latency is going to impact how quick those updates are available between one side of the conversation and the other. So this is going to be pretty bandwidth and latency sensitive. If we look at the monitoring traffic, it's typically more transactional. So it's going to be more based on number of transactional events, radius accounting, radius authentications, things of that nature. So keep that in mind as well too. So we're just going to put more, this is more transactional. If we look at the radius traffic, radius is typically a bunch of small packets, but it is pretty transactional and it is pretty latency sensitive. Because obviously, when I'm authenticating, that's more or less a real-time task, and I need to make sure that my authentication servers are responding appropriately to my network access devices. So this is more latency sensitive here. And this reference traffic is going to be kind of a combination of both. It's not a lot of data, but it can be depending on how much information you're pulling back. And latency is going to impact just how quickly that's displayed because, again, we have to reference that node and pull it back. So now let's take a look at real quick what happens when things don't work like we've designed them. What happens if the PAN fails and I promote the secondary PAN to the primary PAN? Well, pretty straightforward. What's going to happen is all of this database traffic is going to shift from the PSNs to the primary PAN to the new primary PAN. So again, this actually takes this bandwidth and latency sensitive piece and shifts it from this link down to this link. So what does that mean? Well, if we've got like-to-like data centers or active-active data centers, they're probably both designed to the same standards from a bandwidth, from a latency, from a connectivity perspective, or just from a default network perspective. A lot of times people will have a primary data center and then they'll call it a secondary data center, but that secondary is really just a failover data center. They only use it in the off chance they have a significant disaster with the primary. Well, the problem with that is a lot of times the connectivity isn't the same as the primary. So if I have to shift all of this traffic down to the secondary node that I've made primary and the connectivity to him is different than the primary node, then the overall responsiveness and behavior of the design might be impacted. So keep that in mind. What happens when the monitoring nodes fail? Well, remember, they're both active. So I'm getting a copy of the monitoring traffic from the PSNs to both monitoring nodes anyway. So from a day-to-day bandwidth perspective, transactional perspective, probably not a lot of difference. The thing to note with this failure scenario is the monitoring nodes also hold the session directory. Remember I said the secondary guy is read-only? So what that means is in a failure scenario, this reference traffic or this logging traffic we talked about here is automatically going to pull from the secondary node. So what that means is primary monitoring node fails because the PAN is doing a health check to the monitoring node. He knows he can't reach him, so he's automatically going to go reference the secondary node to pull that data up to present it to the user. Until I promote the secondary node to a primary monitoring node, he's still read-only. So that means any new session entries, any new sessions that come up are not going to be saved to the session directory until I promote him. So again, just keep that in mind. The reference traffic is automatically going to flip, but he's going to continue to be read-only and not accept new sessions until I promote him to the primary. The PSNs, those are always active, so one isn't dependent on the other, and the flow really doesn't change based on the failure. The only thing that's going to happen is if my primary PSN goes away, I'm going to reference my secondary PSN, and a lot of that is based on how the network devices are configured. So again, if this is on one side of the world and this is on the other side of the world, the latency is going to be a problem from a response time perspective, so keep that in mind when you're designing your system. One last thing I want to call out that we really haven't talked about is we have this concept of node groups. And if you remember, the replication is hub and spoke, so any change here gets sent up to the primary PAN and then back down to the rest of the system. That might not always be optimal. So I've got this concept of a node group, and I'm just going to draw a node group around these two PSNs here. Just going to put NG. Now what that allows me to do is there are different types of attributes which are beyond the scope of this video, but there are significant attributes and less significant attributes. What a node group allows me to do is to have locally connected PSNs that are on the same network segment actually replicate specific attributes back and forth between the two and share that information. This actually optimizes replication because there's less that has to be sent back up and over because they're already updated locally in their group. And it also helps me from a failover perspective, especially if I'm using things like profiling, because if I have a device that's attached to this PSN, he profiles it a specific way, he gets a new attribute, he'll be able to share that directly with his neighbor node groups so that if somebody authenticates over here for some reason, he actually has that information already available. So hopefully this has given you an idea of the data flow in an ISE design and what you should think about to make sure that not only on a daily basis or a normal operating perspective that things are behaving appropriately, but when things fail that they're also going to behave appropriately and not impact the end users.